Hey guys, today I'm going to talk about molar mass and how do we calculate molar mass. So let's jump in. First thing really is, what is molar mass? We haven't used this term yet. We've used atomic mass, we've talked about average atomic mass, we've talked about mass number, but we have not actually talked about molar mass. So the molar mass is the mass of 1 mole of a substance, where the substance is an element or a compound. So when I say mole, I don't actually mean like an animal, mole like on the screen, but what a mole is a substance that's equal to Avogadro's number. This is a big important number for us. This number is 6.02 times 10 to the 23rd atoms of that substance. So if I have 1 mole of carbon, I have 6.02 times 10 to the 23rd atoms of that carbon. So just a mole is a unit for an amount of a substance. It's a way for us to really look at amount of atoms without having to use huge numbers like 6.022 times 10 to the 23rd, because that's 23 zeros at the end. So where do we find an element's molar mass? On the periodic table, actually. That number we've been using at the bottom, that is the average atomic mass, but it's also going to be in grams per mole, which tells me how many grams is of 1 mole of that substance. So we could say we have 6.022 times 10 to the 23rd carbon atoms, or we could say it's 1 mole of carbon atoms. We could also then weigh it out and put 12.01 grams of carbon onto a balance, and that would be 1 mole of carbon. This is where we're going with this unit. We want to actually figure out, though, how can we calculate the molecular or compounds of molar mass? So the first thing we want to figure out, though, is how do we sum it? It's the sum of all of the parts of this. So what we're going to do is I'm going to look at C6H12O6, and I want to find what the molar mass is of this. So I'm going to use my periodic table here, and I'm going to look at carbon. Carbon has a mass, and you can have 12.01. So 6 times 12.01, that's how much the mass of carbon is, plus 12 of 1.01, so times that in, plus 6 times oxygen, which is 16. So when I plug this all into my calculator, I'm going to take 6 times 12.01 plus 12 times 1.01 plus 6 times 16, and this gives me 180.18 grams per mole. So if I wanted to find the molar mass of this, I'm just going to take and add up each and every little piece that I have. All right, let's keep looking at this. So I'm going to go through and do a bunch of these just so you can really see this process repeated out for you a couple times. Oh my goodness, my thing. There we go. So I'm going to find the molar mass of H2O, of water. Now looking at this, I have 2 hydrogens and I have 1 oxygen. So if I want to do this, I'm going to go 2 times my hydrogen mass, which is 1.01, plus 1 times 16. Plug that into my calculator, 2 times 1.01 plus 16. This gives me a molar mass of 18.02 grams per mole of water. All right, calcium carbonate. We've got 1 calcium, 1 carbon, and 3 oxygens here. My work, I'm going to find my calcium atomic mass, which is 40.08, plus carbons, which is 12.01, plus 3 times 16, because 3 oxygens. I'm going to plug this into my calculator. This gives me 100.09 grams per mole. I'm going to show one more, and then if you feel like you're good, you can probably stop here, but I am going to work through the rest of them just in case. I have 1 sodium and 1 chlorine. Sodium is 22.99 plus chlorine, which is 35.45. I'm just grabbing that mass off the bottom of my periodic table. And together this gives me 58.44 grams per mole. All right, if you followed along so far, I think you're probably good. If you haven't, I'm going to do the second row of these just to make sure. They do get a little more complicated as we get to the bottom. Down here I've got 1 calcium. I have 2 nitrogens because that 2 has to go in, and I have 6 oxygen. So calcium is 40.08 plus 2 times my nitrogen, which is 14.01, plus 6 times 16. I'm going to plug this into my calculator real quick, which gives me 164.1 grams per mole. Chloride, we've got 2 chlorines. We're going to take 2 times my chlorine, which is 35.45, which gives me 70.9 grams per mole. And then my last one, I've got 3 beryllium, 2 phosphorus, and 8 oxygen and beryllium phosphate. So we've got 3 times 9.01 plus 2 times phosphorus is 30.97 plus oxygen, which is 8 times 16. Plugging all this in, 3 times 9.01 plus 2 times 30.97 plus 8 times 16. Beryllium phosphate's got a molar mass of 217.48 grams per mole. All right, if you stuck with me this long, thank you, and I hope this helps you guys calculate this.